through a number of operations that are carried out somehow randomly. So let us list some of the possible operations. So first, it might happen that we have a two-part and we change it into or two nodes and we change it into three nodes. So we can create a new node in the structure. But to be honest, the operation might work in the opposite direction as well, so that we might forget one node in the structure. So with this kind of operation, we can develop a complex circuit like this. This has 1, 2, 3, 4 nodes, or a complex circuit with 60 nodes out of a parent with 2 nodes only. Well then, of course, there is another important possibility. We have, for example, an inductor connected between 2 nodes or any other element that is in the element library of the program that does the development, and we change it, for example, in a capacitor. And of course, vice versa. Then, of course, there is a very, besides those great changes that change the number of inner nodes or the behavior of those things connecting the nodes in a qualitative way, we can also only change quantity, like we have a resistor of 100 ohms and we change it into a resistor of 120 ohms. Well, that's a cosmetic change when compared to changing the numbers of nodes. And now we can run this for many times. We are talking about 100,000, for example, of new trials, possibly millions of trials for complex circuits or complex needs. I mean, if you have a sophisticated demand on the circuit, you would need possibly many operations like that. It might be useful in some cases later in the design that instead of randomly changing values, you start gradient optimization to find optimum with a fixed number of nodes and prescribed characters of those elements. But anyway, this something is capable of developing circuit schematics and values of the elements that fulfill your design goals. Well, frankly speaking, for example, if you decide to create a filter, a frequency filter, so something like a Butterworth filter, a low-pass circuit, so this is a low-pass circuit of 5th order. If you use classic circuit theory for a given passband and given attenuation out of band, you will get an exact formula for the number of elements, for the order of the filter, and you will get an exact formula for the values of inductors and capacitors, and you will get an optimum design. So it's proven that for this input goals like passband and stop band attenuation, if this is frequency, and we will have the, for example, transfer function. So if you want to get a filter which looks like this, you can get an optimum solution using circuit theory for Butterworth, Chebyshev, and other types of filters that have additional properties like minimum phase change, minimums, group delay, or other important design criteria. And running this algorithm will not give you that optimum filters. We ran that, we have designed filters, diplexers, amplifiers, and yes, even with the best solutions, we get, for example, an amplifier that unfortunately had a resistor, a transistor which generated power, and a resistor later which changed that power into heat. The whole design was within specifications, but where an engineer would put 2 transistors, the computer put 3. So those were not optimum circuits at all. On the other hand, this approach is capable of finding solutions where there is no theory at the time being, and those are possibly not optimum solutions, but those are solutions that are truly generated by artificial intelligence. So, although this is not on the market today, and it will not be on the market for next years, one day there might be computer programs that design circuits or cars or I don't know what, that will completely find out the structure, not only the values of components. Well, fortunately, this is not tomorrow, so please do not stop learning. Your abilities will still be needed on the market for next few years at least. So now place your questions.
So like this, we could get a computer to design a better computer by itself.
Well, yes, thus as I will reply in 2 ways. We can, if you mean whether this is physically possible, yes. Whether you ask we can, that means I have a program that can do it now, I do not. So it will still need a lot of work, but it seems that this is the future. I do not know whether I like it or not, because I like to work in the lab and design by myself. But anyway, the artificial intelligence would be able to do things that are quite difficult to imagine now. Was that a reply to your question?
Yes, thank you.
Are there other questions now? Well, if there is no other question, I would like to make a 5 minutes break and get a coffee, and then we will continue. So 5 minutes break. Bye bye.